Hi all, welcome to Graphics Desk.
In this video, we'll talk about problem related to engineering curves. And the problem statement is, a circle of 20 mm radius rolls along the straight line without slipping. Draw a curve traced by the point of the circumference for one complete revolution of the circle. So, let's begin. So let's draw a horizontal line first. This is the surface on which the circle is going to roll. Let's locate have a vertical line which will be the center of the circle at initial positions. So let's draw a circle of 20 mm as given in the problem. From this point we locate the center, and from that center we draw a circle. Now let's divide this circle into 12 parts. So first of all we'll mark a horizontal line passing through the center. And then using these 4 points, we'll cut the circle into further 8 points. Now let's connect the opposite points to each other so as to get the 12 equal parts. Now the direction in which it is going to roll is this direction, and the path in one cycle it will complete would be the 2 pi r. So we'll have to first figure out what is the path or length that the circle will cover in one cycle, which will be 125.6 mm. So let's measure 125.6 from this point, as it is a starting position. Now this is the complete path that a circle will complete in one rotation, and at the end of it we'll have the same point at this place. So now we have to divide this line also into 12 equal parts. So what we'll do is we'll take any inclined line at any angle and we'll mark that in. So we'll take this inclined line and we'll have 12 equal parts of this line. Right, so this is the line and 12 equal parts. Now for us to divide this line into 12 parts, we have to connect this point to this point. And any line parallel to it passing through these points will divide this into 12 equal parts. So let's draw those parallel lines. Now the reason that we have divided this into 12 parts, we have to locate the location of point C, which is center, at all the time during the journey of this or the rolling of this circle until the end. So we'll draw vertical lines from here and locate the centers. and a horizontal line passing through it will connect all these 12 lines here. So during the rolling of this cycle, the center lies at these different positions at 1/12th period of rotation. So this is C0 position, that is the starting position. This is C1, this is where the center would be after 1/12th of rotation. This is C2, C3, C4, C5, C6, C7, C8, C9, C10, C11 and C12. That's the final position. Now we have to trace the point on the circle, not the center. So we have got the center, but we have to locate the point at every single time of this journey. So we'll have to draw the horizontal lines or horizontal lines parallel to XY from these points. So let's draw that. Now radius of our circle is given as 20 mm. So this will be 20 mm, and from each center point we have to locate a point on respective projection. So point C1 as a center, we'll cut this line. Let's name this point as P, P0, because this is starting position. This will be our P1. From C2 to second is P2. Let me do it for all. Now remember here from C6, at C6 it will be exactly on the top, because at C6 point the circle have completed half the rotation, and all the points after C7 would be in the forward direction as that of center. So let me use red pencil to locate these points that I've already highlight these points which I've already located. Okay, so this is P1, P2, this final P12, which will be on the same line, and it is exact same position as that of P0. That's why the second circle will start, but we don't have to discuss it here. So let's connect these points. You have to draw a freehand curve. So this is how the curve will look like. Let me just highlight it. Now this is how the final curve will look like. Now additionally, in certain cases, now in this problem it is not mentioned which point that we have to trace the path for, but in certain cases it would be mentioned as point touching the plane, or point would be on the top of the circle to begin with. So let's see how the curve will look like for a point if it starts from the top. So again, the same thing that we have to do, we have to use same radius from C1, but we'll have to connect or cut to the projections from top until the bottom. So I'll show you. It will be similar curve but slightly different visualization. You can see at C6 it is coming to the bottom, that is at the halfway mark, the one which started at the top is touching to the bottom. So on C7 onwards, this will be on the forward direction. Now let's call this point as Q. So this is our Q0. And this is our Q12. So let's draw a curve through these points. I'm using blue pencil so that we'll be able to visualize how that looks. So this is how the curve of point Q would look like. Now, one thing to note here is that when we are starting the point from the top of the circle, it meets at C6 at the bottom and goes back at P12 or position 12 at the top as Q0. And these curves intersect to each other at P3, P3Q3 and P9Q9, which is exactly quarter and half, quarter to 1. Okay, so this is how it will look like. The red curve is if we are starting the point from the bottom of the circle or the contact point to begin with, and Q curve, which is blue curve, is when we are starting or considering a point which is at the top at the initial position. So this is how the final solution would look like. Thank you for watching this video. We at Graphics Desk committed to spread the knowledge. Be a part of this journey, share this video and spread the knowledge. Until next time, bye.